Hi, my name is Ralph Spurlento, and I will be giving a presentation on how to solve a stoichiometry problem with a limiting reagent and a percent yield. To show the problem that we are going to solve today, it is solid copper 1 oxide reacts with oxygen gas to form copper 2 oxide. If 4.18 grams of copper 1 oxide reacts with 5.77 grams of oxygen gas, what is the theoretical yield of copper 2 oxide? If the actual amount of copper 2 oxide obtained is 4.28 grams, what is the percent yield? Below is the chemical equation that will be necessary to solve this problem. Looking at the 4.18 grams, that's the starting mass, and so is 5.77 grams. But before we get into the problem, here's the periodic table. The periodic table has the chemical symbols for each element listed in order of increasing atomic number. Below each chemical symbol is the atomic mass of each element. To calculate the molar mass of each compound, we will start by looking at Cu2O, which is copper 1 oxide. Copper has a mass of 63.54 grams per mole, and there are 2 atoms of copper in Cu2O. Oxygen has a molar mass of 16.00 grams per mole, and when you add the two together, the two copper and the 1 oxygen, you get a total mass of 143.09 grams per mole. The same method was used to calculate the molar mass of oxygen gas, which is O2, and it has a molar mass of 32.00 grams per mole. Copper 2 oxide, or CuO, has a molar mass of 79.54 grams per mole. But before we can actually solve the problem, we need to balance the chemical equation. The goal of balancing a chemical equation is to have the same number of atoms on each side of the equation, or the arrow. To start, you would initially want to balance the copper because there is 2 on the left and only 1 on the right. But by doing this, you would have an even number of oxygens on the right side, and as you can see on the left side, there's an odd number. So to correct this, we are going to first put a 2 in front of the copper 2 oxide, or the copper 1 oxide, Cu2O. Now there is 4 copper on the left and only 1 on the left. So we will balance it by putting a 4 by CuO. When looking at the oxygen, there is 2 from the Cu2O and 2 from oxygen gas, and there is 4 on the right side. That is balanced. To determine the limiting reagent, you have to look at the starting mass of the 2 starting materials. You start with 4.18 grams of copper 1 oxide and 5.77 grams of oxygen gas. So starting with the 4.18 grams of copper 2 oxide, you use its molar mass to convert it to moles by unit canceling. You then use the mole to mole ratio using the coefficients from the balanced equation. Then you multiply by the molar mass of the final product. You want to convert both starting materials to the final product so that you can compare apples to apples. What's the use in seeing which one is less if they are not in the same units? Now, we will do the same thing with oxygen gas. We have 5.77 grams of oxygen gas. We use the molar mass to convert it to moles. We then use the mole to mole ratio to convert it from oxygen gas to CuO. We then multiply by the molar mass of CuO and compare the two. As you can see, this one is smaller, so it is the limiting reagent. It is also our theoretical yield because that is what we would assume it would make. Now we can calculate the percent yield. Our actual we calculated on the previous slide, and the theoretical was actually given in the problem. We can then plug it into the equation in the picture above. 4.28 divided by 4.65 times 100 yields a 92.04% yield. To conclude, this is a simplified approach to solving stoichiometry problems with a limiting reagent and a percent yield. In this We collected background information such as molar masses to solve the problem. We then balanced the equation, identified the limiting reagent, calculated the percent yield, and now we can finally enjoy solving stoichiometry problems. Thank you.